with the what problems we got in here, but definitely you can have some supplementary videos as well. But anyway, lesson 8.2. Right, thank you. We are now going to work on what we call the sample proportion distribution as well. So what's the difference between the sample mean and the sample proportion? For a sample mean, typically the variables are continuous variables, okay, or continuous quantitative data set. But in here, sample proportion, we said in here, Kalina, let's read this one first. Yeah, used for
Classifying if individuals does or does not have a certain characteristic.
Thank you. Okay, so this one, it doesn't really measure individuals' values, like their heights, their weights, their EQ or IQ. It's not that. This is more of like whether or not individuals do a certain characteristic, do a certain activity, obtain a certain characteristic, right? And we're gonna see later why our problem later will be such, okay? Now, we have certain variables in here that we need to work on. The first one is what we call P hat. And what is P hat in here? Mason, what did it say here?
Sample proportion.
Thank you, right? So that's the sample proportion. That means what? What do you mean by sample proportion? That means what? Well, you divide how many individuals in the sample has that characteristic over the total sample size. Okay, so the P hat or the sample proportion means what? Well, how many of that sample size obtain a certain characteristic over the total sample size. How many people were actually on that study? Okay, so that's your sample proportion. Now, in terms of shape, center, and spread, we have the following in here, right? So let's read in here in terms of shape, all right? Journey, let's read. As n increases,
as n increases, shape of sample
P hat, yeah, correct.
P hat becomes normal.
Thank you, right? So very good. P hat is the sample proportion. Again, as your sample size is big enough or increases, then the shape of your sample proportion will approximately be normal. So we can use the normal distribution for that. And how do we know if it's big enough? Let us have this formula. So what is the formula in here? JC, let's read this one in here. NP times
1
minus P
minus P.
greater than or equal to
Yeah, then equal to
10. Thank you, right? So n in here is what? The sample size, right? So how many were in the sample? The P in here, not P hat, P. P in here is the population proportion, okay? So in most cases, it's already given, okay? So if you have that formula, and that NP times 1 minus P is greater than or equal to 10, then we can say that your sample size is big enough to assume that your sample proportion is also a normally distributed distribution, shape, okay? Let us read about the center, the measure of central tendency for such, okay? Let's read this one. Braden, can you see it from there? Mu
P
hat
equals P.
Thank you, right? So what do we mean by mu of P hat? That means that's the P hat is the sample proportion, mu is the mean, right? So that means what? The mean of the sample proportion, okay? So this is the sample proportion, that's the mean. So the mean of the sample proportion is equal to what? What is P again?
The population.
Population proportion, okay? So again, the population proportion and the mean of the sample proportion should just be the same. Okay? Again, assuming that this criteria is satisfied. NP 1 minus P is greater or equal to 10. Okay? And the last one regarding the spread, the variation or the standard deviation. Let's read this one in here. Emma, go ahead please. Spread. Sigma P hat.
Sigma P hat equals
Square root.
square root of P1 minus P over n.
Thank you, right? So that's the what? The standard deviation of the sample proportion is equal to the square root of the what's this P again? Population proportion. right? 1 minus population proportion over sample size, right? Last one in here, some analysis regarding this. What's happening to your standard deviation with respect to sample size? How big or how small the sample size, okay? Mason, let's read this one as
N increases,
sigma p hat.
sigma p hat decreases.
Thank you. And similar to our sample mean distribution as well, right? As your sample size increases, then your standard deviation of the sample proportion decreases as well. Okay, well, let's see. Let's read this one in here and verify and answer this question for number 17. Okay. Ready, guys? Giselle, let's go ahead. Let's read, what's this? Marriage obsolete? Let's see. Okay, go ahead, please.
According to a study done by Pew Research Center, 39% of adult Americans believe that marriage is now obsolete.
Thank you, right? So that P, what is that 39%? That basically is your P, right? Not yet, right? That's a percentage. That's basically the proportion of the proportion of the population who believes that what? Marriage is out of date. Is that what you mean by obsolete, right? Out of date. Okay, there we go. Okay, so 0.39. Okay. Again, that is the population proportion. Okay. Let's read letter A and how we can work on that one, okay? Jackie, go ahead, please. Yeah.
Letter A.
Yep. Suppose a random sample.
Suppose a random sample of 500 adult Americans is asked whether marriage is obsolete. Describe a similar distribution of P in proportion of adult Americans who believe marriage is obsolete.
Thank you. Okay. So again, what is our N in here? 500. Thank you. Now, before we continue, let us see first regarding what can you say about the shape of our sample proportion? Okay, let's see what the shape is. So how do we verify that one? It says there, the shape of P hat, okay, or the proportion of sample, the sample proportion should be approximately normal. Should this be correct? And what is that? N P times 1 minus P should be what? Greater than or equal to 10. And let's verify, okay? So how do we answer this? What's your N again? 500, thank you. What's your P again? 0.39, thank you. Okay. And then put in here what? 1 minus 0.39. Okay, and let's verify. Is that greater than or equal to 10? So just use our calculator for such, alright? So let's put it in here. 500 times 0.39, there we go, times parenthesis 1 minus 0.39. By the way, P is the population proportion, okay? And what did we get? Anyone who got a value for such? How much is this? Again, we are trying to verify if that's greater than or equal to 10. What did you get? On my end, I got the following, approximately 119, and yes, it is greater than 10. So yes, in terms of shape, your sample size is big enough to say that P hat, and we can put in here now, P hat is normally distributed. Okay, that means the sample proportion is normally distributed. Since we got this one to be greater than 10, okay? Now, with that being said, what can you say now about the center? It says here what? What is P hat then? Again, P hat is equal to, what did we say a while ago? Or mu of P hat is just equal to the population proportion, right? So what's that gonna be? Equal to?
0.39.
0.39, okay? Very good. Thank you, Mason. That means the population proportion and the sample proportion should be the same, okay? Now let's read letter B and how we can answer this one, okay?
What
Juliana, go ahead please.
is the probability that in a random sample of
so what we have in here for letter B is the following, right? The probability that your p hat, okay, yeah, that's the sample proportion, is what? Less than 0.38. Okay, so the probability that your sample proportion is less than 0.38. Well, let's see how we can work on that one, okay? So we're gonna use our decimals for such, again, with the assumption that this is a normal distribution, okay? So here it is. Well, first of all, we said a while ago, what is the mean of the sample proportion? What is the mean of the sample proportion, guys? What did we get? 0.39. Thank you. 0.39. That's the mean of the sample proportion because that is the same as the p hat. Okay. And we can put it in here to be clear with that. Okay. The mean of the sample proportion is equal to the population proportion, which is 0.39. Okay. Next one. What is our standard deviation? What's our formula for that one again? The standard deviation. Here it is. Sigma p hat is equal to, once again, what's that? Square root of p 1 minus p all over n. Right? So with that being said, what's that going to be? Square root of, what's your population proportion? 0.39. 1 minus 0.39 all over, what's your n again? 500. Right? So I'm just going to type it in there for the standard deviation formula. Right? So, what's the shortcut key again for square root? SQRT. Okay. Okay. What's our formula again? P. 0.39, 0.39. Parenthesis, 1 minus 0.39. Right? Over sample size 500. Okay. Good. So again, I just type it in there for the standard deviation. Now, what did we say a while ago? What we need to get? What we need to get? That the probability. Can you read it again, guys? What we're trying to get?
Less than 38%.
Thank you. Right. The probability that the sample proportion is less than 0.38. Right. 38%. So when you say less than, where do we put the 0.38 now? Is it the maximum or the minimum value?
Maximum.
The maximum value, right? That's the maximum, and all values lower than that is considered, right? So I'm going to remove this 3.6 and put the maximum to be 0.38. Okay? Now, to visualize, Mr. Deal, where's the graph in here then? So here's what I'm going to do. I'm going to click in here on my graph settings, just to let you see where it is. On the X, I'm going to put what? It's 0.39. So I would say something somewhere from 0 to 1. Right? So there we go. Because this is proportion, so it's 0 to 1. And your Y-axis, you can put it 0 to, I think, what is this in here? Let's see how we can see that. 5 or just to see how.
Yeah, you just go to stat and then calculate your normal.
Change your life.
Okay, so just to give you an idea of where the graph is. So here it is. Where's the mean again? So the mean is in here. Okay. That's the mu of p hat, which is how much? 0.39. And this value in here, this part, is your what? P hat equal to what? 0.38. Okay? And these are values less than 0.38. And how much is that? 0.3233. That is the probability, right? That the sample proportion is less than 0.38. Right? In some wording, we can say that this is the most value, right? Yeah, if it's at most 0.38 in some wording as well, okay? Any question regarding what we did with the sample proportion? Definitely by tomorrow, gonna work more on this one. But again, for a summary, make sure that the sample size is big enough. NP 1 minus P should be greater than or equal to 10. If that will be the case, then P hat is normally distributed. Then that means whatever your population proportion is, so it's the same mean of your sample proportion. And your formula for standard deviation is this. Okay? And typically in your calculator, you're just gonna plug it in like so. Just to avoid those round off errors. Because honestly in here, usually the problem is this round off error. So you want to put it in there as a formula. Okay? Not as a value. Okay? Just to remove those random error as well. Okay? Thank you so much.